This is Mrs. Jones, and I am back for part 2 of solving multi-step equations. And we're going to pick up where we left off from the first part. So we are now going into inverse operations. Okay, inverse operations, not too bad. It's basically what you've been doing in math in the past. So you could have anything from the inverse of adding, like this one would be to subtract, right? And you would take 4 away from both sides of the equal sign, and that would give you P is equal to 3. And then we have the inverse of subtraction, not bad at all. So if we have minus 2 equals 8, you would do the inverse of subtracting 2 and you would add 2 to both sides. Those are inverse, so they cancel, and you're left with P is equal to 10. One part that does confuse students a lot is if they have a problem that looks something like this. Let's say you have a negative 5 plus x equals 6. Okay, and they look at this problem and you think, oh, well, this is addition. I want to do the inverse. But what you want to actually do is the whole goal in this is to get this x all by itself over here. So this is what you want to move. So if you're going to move this, you need to do the inverse. And it's a negative, so you're going to add 5 to both sides. Because just like here, these two had the opposites, and these two had the opposites. In order to cancel, those have to have the opposites in order to cancel. And that leaves you with x is equal to 11. Not bad at all. All right, so let's look at a couple examples then, real quick, of the inverse of multiplication and division. The most common you're going to see would be if you had a multiplication like this and you want to do the inverse. This is 3 times x, so the inverse would be to divide. Now, class, one thing I want you to do is when you divide, don't put the division sign like this. Okay, we're not going to use that right now in pre-algebra. Instead of using that, we want to put the line. So those will cancel, and that will leave you with x is equal to a negative 4. Always watch your positives and your negative signs. And then the last example here I want to show you is if you have something such as y divided by 4 equals 2. So in this, you want to isolate the variable. This is division. So you're going to do the opposite, and you're going to multiply times what's on the bottom. So you're going to multiply times 4. So these two would cancel, and you would get y is equal to 8. So just a real quick review of inverse operations. All right, now let's dig into some problems. We're going to start with some pretty simple multi-step equations. And just real fast to review, first we're going to see if we need to use the distributive property. We check that first. We see if we need to combine any like terms on either side. And then we're going to start getting into inverse operations. First step of the inverse operation part, move all the variables to the same side. And then we're going to move all of the numbers to the same side. That would be like the constants, those numbers that are by themselves. And then we're going to use inverse operation, and we're going to move it so we can get that variable isolated. We want to get it all by itself. So here we go. Let's do an example. We're going to start with an easier example, and then we'll just kind of get harder as we go. And the main part of this I want to stress to you. Let's say right here is where I'm going to write the problem. And let's say the problem is written in there, it has an equal sign in it, and let's say you have a variable in there of x. Guys, I want your goal to be, you're basically going to want your problem to go down in this fashion to where down here at the end, you would have like x is equal to. Because the whole goal is you're trying to solve for that variable. So you have a big problem, bring it down, bring it in, and then you have your answer at the bottom. All right, here's then our first problem that we're going to solve, working it in that manner. Okay, so let's do p minus 1 is equal to 5p plus 3p minus 8. All right, I do this thing called draw a river. I look at the equal sign and I draw a straight line going down. That's because I want to keep that equal sign right down this river. Just like, guys, here, look, this equal sign is lined up with the equal sign in the answer. That's what you want to always do. Work your problem going down, not across. Okay, let's look and see if we can find step 1. Step 1 said to use the distributive property. Well, I don't have any parentheses here, so I can skip that. So I go to step 2. Step 2 tells me to look on either side here and then over here and see if I can combine any like terms. I can't combine those. Over here, well, look, I have, that's a P and that's a P. So my first thing I'm going to do is combine those. Now, anything that you can't work with, just bring it straight down. Bring the equal sign straight down. 5p plus 3p, is 8p. And then bring down the minus 8. All right. Now we're ready for the next step. Step 3 says to get all of the variables on the same side. I have a p on this side and I have a p on that side. I don't want it on both sides because the goal is to get that variable, like up here with the x, all by itself. Well, I like to move the smaller p. I think that just gives us an easier problem to work with. So if we have this one, and it's an understood 1p. 1p is smaller than 8p. So I want to move the 1p. To move anything over there, you have to use inverse operations. It's a positive 1p, so I'm going to subtract 1p from this side and subtract 1p from that side. Okay, anything over here I haven't worked with yet, I'm going to bring it down. Well, I haven't done anything with this minus 1, so I'm going to bring it straight down. Going to bring down the equal sign. 8p minus 1p, 7p. And now I'm going to bring straight down on the minus 8. All right, I'm ready for step 4. Step 4 says to get all of the numbers on the same side. Basically, the constants. So that means I want to move, oh, there was Bella or Piper barking. I want to move this number. That's the constant. I want to move it over there because I'm trying to get this p all by itself. So I'm going to do the inverse. I'm going to add 8. I'm going to add 8 on that side, and I'm going to add 8 on that side. And a negative 1 plus 8 is 7. Bring down the equal sign. I haven't done anything with that now, so I'm going to bring it down. And that's going to cancel because they're inverse. And look, I'm on my very last step. I want to isolate that variable p. So it's 7 times p. The inverse would be to divide. And my final answer is p is equal to 1 because 7 divided by 7 is 1. And there is my answer. All right, I can go back up in my problem and I can check and see if that's right. So I'm going to take that 1 and I'm going to substitute it in for each p. So that's going to give me 1 minus 1 equals 5 times 1 plus 3 times 1 a minus 8. 1 minus 1 is 0. 5 times 1 is 5. Plus 3 times 1 is 3. So 5 plus 3 is 8. And 8 minus 8 is 0. So yes, that is the correct answer. All right, let's work another multi-step equation. Here goes our next one. All right, the problem that we are going to work is 12 equals a negative 4 times a negative 6x minus 3. Now, I hope the first thing you saw is we're going to do the distributive property because we have a parentheses here. So that is going to be our first thing, and that's step 1. So I'm just going to bring that down, put the equal sign here, and I'm going to distribute my negative 4 times everything inside. So a negative 4 times a negative 6, 24x, and a negative 4 times a negative 3 is 12. Now it's time to solve for the x. This is called a two-step equation, and I am now down to step 4 because I don't have any like terms to combine on either side. So step 4 wants me to do the inverse operation and move the number that's with the x. So I'm going to subtract 12 from this side and from that side. And that's going to give me 0 equals 24x. And now I'm going to do the inverse of multiplication and divide. And our answer is 0. And if you plugged in the 0 here, you would end up getting a negative 4 times 0, 0, and then a negative 4 times a negative 3 would be your 12. Okay, let's go down and let's do one that's going to have a lot in it. Okay, so here we go. Here's a big problem, and this is going to be the last one that we're going to do. All right, here we go. Let's do, I hope you're ready for this one because you're going to see it's going to be big. We're going to have a negative 5 times 1 minus 5x plus 5 times a negative 8x minus 2 equals a negative 4x minus 8x. Wow. Now look at this. This looks overwhelming. But if you just take it step by step, like I told you, it's easy. Okay, so let's put our little river here. Step 1, do the distributive property. Look for parentheses. We have it here, and we have it here also. So we're going to do it in both places. Okay, a negative 5 times 1 is a negative 5. A negative 5 times a negative 5x is a positive 25x. Let's do distributive over here now. 5 times a negative 8x, positive times a negative is a negative 40x. And a positive times a minus 2, which is just like a negative, is a minus 10. And then I'm just going to bring these down because I haven't done anything with them yet. That was step number 1, the distributive property. Okay, now we're on step 2. Step 2 says to combine any like terms on each side of the equal sign. So let's just look over on that side. All right, I'm going to cover this side. We're not going to do anything with it just yet. So I'm going to look for any like terms. Well, here's a number, and here's a number. So I know I can combine those. And then, look at these. These both are x's. So I know I can combine those. All right, so let's say I'm a negative 5 minus 10 is a negative 15. And now we want to combine these two. We have for 25 minus 40. So you want to find the difference in 40 and 25, which gives me 15. And it's going to be a negative 15x, because this one's larger and it's a negative. Put your equal sign here. So all I've done is combine these that I have in the square and then these two that I have in the oval. Now let's look at this side. Are these ones that I could add, are they like terms? Yes, they are. And so when you combine those, you get a negative 12x. All right, now we're ready for step 3. Step 3 tells me I want to move all of my variables to the same side, because I have an x on this side and I have an x over there. I don't want an x on both sides. So I'm going to move one. Well, if I moved that x, I wouldn't have anything over there. Well, that's not going to really help me. So I'm going to move this x. So I'm going to add 15x here. And I'm going to add 15x here. Like that. That'll cancel. So I'm going to bring down this right here. This just came from there, okay? I'm going to bring down the equal sign, and a negative 12x plus 15x gives me 3x. All right. The next thing I'm going to do in this problem is I am going to divide both sides by 3, because the inverse of multiplying times 3 would be to divide. So I'm going to divide both sides by 3. Those cancel, and I get x is equal to a negative 5. And that is my final answer of this humongous problem. Step by step, do the distributive property, combine like terms on either side of the equal sign, get your variables on the same side using inverse operations, and then we skip down to step 5, and that is to isolate our variable. We did the inverse of multiplication and we divided. And that is multi-step equations. Thank you.